So I have the answers to these already. We'll go over the answers, any work I have. I know many of these you did like in Desmos or your calculator. If you want to see a specific one in Desmos or your calculator, we'll do that. And go through. So for number 1, remember 0 is another word for x-intercept. So your 0 for this one, if you solved it, this was the word for that. If you put that in your calculator or Desmos, you would have got the intercept of 6, 0. For number 2, it shows you the graph. Solution is another word for x-intercept. So you just had to find what was your x-intercept, and that was at this point right here, negative 2, 0. For number 3, so I think I said use Desmos or your calculator for that one. Roots is another word for x-intercept. So if you graphed that in your calculator, it would give you this decimal, negative 1.50, and then the other one was right on the grid line, 2, 0. And then I had you guys skip number 4. So I'm going to talk through number 5, because I know that one was a little confusing. So what it wanted was these two equations to have the same x-intercept. So to do that, I took this first one, the g of x, and I found my x-intercept. You could have done that by hand or in the calculator. So I found my x-intercept to be 6. I don't have this up here, but I'm going to write that as an ordered pair. Now that I have this ordered pair, I know that my second equation needs to have that same x-intercept. I put 6 and 0, my x and my y values, into this equation. That's why there's a 0 and a 6 there. And I solve for k. Because that is the end goal, I need to figure out what value of k will give me the same equation, or the same intercept. So I put 0 and 6 in, and I solve for k, and I got negative 18. And then this last step in blue is just me putting in negative 18 and seeing, will I still get the same x-intercept? So I put in negative 18 for k. I set this equal to 0 just like I would a regular equation if I'm looking for the x-intercept. And I solved it, and I got x equals 6, which is that same x-intercept. The final answer is really this negative 18. But the part in blue is just to check that it works.
And then make it 18 equals something.
Any questions on that one? I'm still writing. I'll give you another minute. Yes. Another one. I'm going to scroll up really fast and come right back. 6, 0. Right here. It was the same answer for number 1. If I need to come back, just let me know. For the second page, you can put all of these either in your calculator or in Desmos. there is a way to put them all in your calculator, but it gets kind of hard on your calculator because you can't see colors. On mine, it would be nice because I could see all of these in different colors and see where they cross on the x-axis. Or Desmos would be better. So when you put all of these into Desmos, only these three cross or touch the x-axis at +3. So those three were your answers. For number 3, if you put that in Desmos or your calculator, that was fine. If not, this is the work for your x-intercept. Your y-intercept would be that -4. X-intercept was 4/3. I wouldn't put that as a decimal because it's a repeating decimal, so just leave it as a fraction, 4/3. Number 4 asks for the y-intercept of this graph. So you looked and found where does this cross the y-axis, and it would be at this point at 4. So 0, 4 was the answer. And then for the last one, it asks which of these have exactly one x-intercept. So if it crossed or touched the x-axis more than once, it would not have one intercept. If it did not touch it at all, it would not have one intercept. So you needed it to either go through the x-axis once or touch it at one place. And only these two did that. Do we have any questions on any of these? Need to see any of these? Question number 3. Any others we have questions on? Need me to go back to? Really quickly, before we start our new set of notes, did we have any questions on Delta Math or Khan Academy that we weren't sure about, we got stuck on, we wanted to go over? I'll give you a second if you're looking. Just a reminder that there was a Delta Math. I don't know if I said that last class. But you can go back and do that. The intercepts one. There are 2 Khan Academies. They're not due until Friday. Intercepts from a graph, intercepts from an equation. So if you haven't done those already, just make sure you do them by Friday. If while you start doing either of those or any of those, you need help or something doesn't make sense, or you have a question about something, you can come after school or before school and we'll go through that together. Or if we have time in class, we can do that then. Last time I'll ask about that. Anyone find a question they had or wanted to go over before we move on? For those of you that had your computer out, you can put them off to the side, close them, you don't need them right now. You should have the next set of notes on your desk for slope. Like I said last class, A lot of this might be review for you. Some of it may be new to you. So this first page has some notes. I'm going to let you guys fill those out. And as you're filling it out, I'm just going to talk through it a little bit. So just in case you can't see that, I'll read it out loud. A rate of change, in that it says a ratio that shows how one variable changes with respect to another. On a linear graph, this is called the slope of the line. So rate of change and slope are interchangeable. If it asks you to find the rate of change, it's really asking you to find the slope and vice versa. Slope is written as a ratio of the vertical change, or the rise, to the horizontal change, the run, between any 2 points on a line. This remains constant for any 2 points of the same line, or on the same line. This means between point A and point B, whatever the slope is going to be the same between point C and point D and point E, and so on and so forth. The slope is never changing. Slope is written as a fraction in simplest form, so ratio can be written multiple ways, but the way we are going to write slope is in fraction form, simplest, improper if needed. And the variable for slope is m. Slide this down just a little bit so you can see all of it.
Slope is rise over run.
Yes. So there are a couple different ways we can find slope. One is from a graph, and then the other way is algebraically. When you have slope from a graph, you guys don't have this, so I would draw in these like x and y axis.
You actually draw them in different shapes, like short on that side? Or
No, I just
plus signs?
didn't do that. They're all supposed to be equal, but
So they're all the same shape. All the same shape.
these are just your x and y axis. I'm going to actually draw in the graph here in a second. So there are 4 different types of slope: positive, negative, zero, and undefined. These are all of your different slopes that you may see. If you have a positive slope, if you're looking left to right, it's going to go in this direction. With positive slopes, you have to think of positive directions. Up and right are positive. Down and left are negative. So if I'm reading left to right and our slope is rise over run, we can go up and right as a positive direction. Or if I'm reading left to right, right to left, since I have to go up or down first because of my rise, I can go down and left. Down is negative, left is negative, and 2 negatives make positive. So either way works. Yes, Javier.
What's that, the one next to types of slope? Is that a 1?
Where?
Next to where it says types of.
Types
The
of.
blue arrow.
Yeah, this is a up arrow.
Right.
And then a right arrow.
Okay.
Showing you the directions you can go. So for negative, looking left to right, it would go this direction. So my rise would be down, my run would be right. So that's one way we can look at a negative slope. The other way for looking right to left, if I go up and go left, that would also give me a negative slope. So with your negatives, only one can be negative, not both, because then it would be positive. So either down or left, not both. For your zero slopes, that was supposed to be more straight than what it was. Your zero slopes are like a straight line. That's like me walking across this floor right now. I have a zero slope as I'm walking. You driving or riding the bus to school on a flat street has a zero slope. Anything where you're like going in a straight line horizontally has a zero slope. Because this does not have a vertical change, but it does have a horizontal change. And then for your undefined slopes, that would be a vertical up and down line. These undefined slopes have a vertical change, but don't have a horizontal change. Those of you that have your calculator, I want you to pick a number, any number you want, and divide it by 0. Yes. What do you get when you divide by 0?
Error divide by 0.
Yeah, so we cannot divide by 0. There's an error message that pops up. Therefore, it's undefined, correct. So positive, negative, 0, undefined are all the different slopes we can get. In this box right here, put m equals rise over run. When we find the slope of the line, we need to find 2 points that cross the grid lines, so the background grid lines exactly. Not like almost, but exactly at 2 points. Yes.
What is the 0, the blue arrow? Is that like 0 divided by the arrow?
0 divided by the arrows, yeah. So like, it's not moving up or down at all, but it is going left and right.
And the one where I'm undefined, what is that?
It's going up and down, but it's not going left and right at all.
Okay. We play equals 0 for undefined?
Put undefined. Sometimes your graphs will have points on there already that you can find and use those. Sometimes you may need to find points that cross your grid lines exactly, and we'll do both. So these do have points on there that we could find, but I'll also show you that there are other ways to find these points. So for this one, if you did not see this, there's a point right here and a point right here. So it does not matter if you do this left to right or you do this right to left, as long as you go up or down first and then left or right. We'll do both. So if I'm doing left to right, if I start at this point, because it's rise over run, I need to go up first. So count how many units I need to go up. You don't have to draw this it just helps me see because I'm so close to the board. I think it is 7. I did that, but didn't actually count. 1, 2, 3, 4, 5, 6, 7. Yeah.
And then 4 over.
So I'm going up 7, to the right 4, up and right are both positives. So I can say that my slope is positive 7/4. I cannot talk today. But if I was looking at the opposite way, and let's say I still saw those 2 points, but I started at this top one, well, my rise, I would need to go down first because I can't go up on this. It's still 7, but now I'm going down. And now I'm going left 4. So because I'm going down and left, that gives me a -7 over a -4. But because 2 negatives make a positive, this would still be 7/4. Sorry.
If it's going left, why is the 4 under the 7 going right?
Because I didn't draw the arrows correctly.
Oh, okay.
So you can look at it either way, it does not matter. The only thing that does absolutely matter is that you have to do your rise before you run. So think about like when you get out of bed, usually you sit up before you get out of bed. For most of us, yes, Aubrey.
Oh, we have to probably simplify or flatten one.
Yeah, so anytime you can simplify, simplify. In this case, we can't because 4 doesn't go into 7, vice versa. But if we can simplify, do that. Any questions on that one? Okay, let's do the next one. There are points on this one, and this one. So if I was doing left to right, that would be 3 units down. And 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. So -3 over 9, but that can be simplified to what? Yeah, you could have said that one. So what that means is every time I go down 1 and to the right 3, there should be another point. So I'm going to test that theory. If I start at this first one and I go down 1 and to the right 3, it does cross the grid lines right there. If I go down 1 and right 3 again, it does cross the grid lines right there. If I did not see those points and let's say I happen to see these ones instead, they weren't there before, but maybe I saw that they crossed the grid lines exactly, I could start there. And it doesn't really matter. If I was looking at it right to left, I would go up 1 and to the left 3. So this would be a +1 over a -3. Really, where you put the negative doesn't matter, but in a sense it also does. You won't really see the negative in the denominator. You'll see it more in the numerator or out to the front. Before we do 3 and 4, I'm going to give you this acronym that will help you determine zero or undefined. This will help you even more when we get into graphing. So somewhere in your open space, write these letters. HOYBUX, Hoybux. I should have actually written this horizontally, but it's okay. So for Hoy, this is horizontal. I'm going to write this vertically though. If you want to change it so that it's written horizontally, you can do that. So horizontal lines, that means it goes left or right. Horizontal lines have a 0 slope. Sorry, I know. I'm just going to rewrite it because reading it horizontally is not good. I don't know why I did that. Hoybux. Horizontal lines have 0 slope. And when we get into graphing and writing, this part will make more sense, but these are going to be a y equals equation. So then bucks is all your opposite things. These are vertical lines. So up and down. Vertical lines have undefined slope. And these are usually x equals. Yes, so
This is horizontal. Not that way. Is that an arrow?
yeah, it's supposed to be a left and right arrow. I'll just redraw it. Better. Dante, can you tap them? We go. So for number 3, this is a horizontal line. So if you see that it's a horizontal line, it's going to have what type of slope? 0. You could still find the rise over run, but in this case, it doesn't go up at all. So my rise would be 0. This does have 2 points, but you could really choose any 2 points on this line. Left, right, or right to left, either way, this goes over 4, but 0 divided by anything is 1. If we were dividing by 0, it would be undefined. But 0 divided by anything is what? 0. So that part's not really necessary if you know that a horizontal line has a 0 slope. Could you still do that? Yes.
So what there is a left to right, which is 0.
Also, get in the habit of putting m equals whatever your slope is. That way you know that's your slope. Michael, are you okay? Number 4 is a vertical line, so that should have what type of slope? Undefined. If you want to shorten it and just put U in D, that's fine. Yes. If you have a vertical line, yes. If you wanted to do the work just like this one, it's not necessary. But you do have a vertical change here. I can say I'm going down, 5. But I'm not moving left or right, so this is going to give me an undefined. Yes. Hold on 1 second, I'll send you. This next page has a bunch of different problems. I'm not sure if you can see it very well. Number 9 and number 12 have horizontal and vertical lines. You may need to outline that. I want you to do as many as you can in the next 5 minutes, and then I'll show you the answers and we'll go through them. So I'll be walking around if you have any questions, but do as many as you can in the next 5 minutes. I had to redo these a lot because I do the wrong ones or something. But let's hope that we all have the same answer. Okay, so I'll just read them out loud and I'll go through them. 7 should have been -3. 8 was 4/5. 9 was 0. 10 was 4/2, which simplified to just 2. Wait, the numbers are off. Yeah. Start with number 5. Okay, my bad. So pretend that this was 5. Sometimes I change the numbers and forget that I changed the numbers. My God.
The number 9, it says it's 1 over 3. Mine says that.
You said that's what?
For us, it's 1 over 3. For number 9.
Yes. Number 10 was undefined. 11 was 4. So any whole numbers, simplify that to, any fractions with whole numbers, just simplify that to the whole number. 12 was 2/3.
No, but fractions, right? I mean, decimals.
Don't put decimals, right? Leave your slope as a fraction. 13 was -5. 14 was 1/4. 15 was +2. 16 was -1. 17 was -3/4. 18 was -1/2. And 19 was 5/2. Do we have any questions on any of those? Say. So you can put the negative in the numerator or out to the front. Audrey? Give me 1 second to make sure everyone has this one. And then back up to which number? 5. And then Adina? So for number 5, I don't know if this point was there yet. So looking at this point to this point, what's that point there yet? If you're doing left-right, you would go down 3 and right 1. If you're doing the opposite, you would go up 3 and left 1. Either way, there's one negative thing in there. So you have negative 3 over 1, which simplifies to this negative 3. Okay. 13. Any others we have questions about? So finding slope from a graph is not difficult. We just have to look for the points and then count. Remember, it's always go up or down first and then left or right. On the next page, we're going to find slope algebraically. You may have seen this before, but many of you may have not seen this before. So this is the slope formula. This is like what we're doing when we find slope on a graph. So we're going to use this formula, y2 minus y1 all over x2 minus x1. This is something you'll need to remember. I will say that some of this can be mixed up. So if you forget which number comes first, if you put y1 first and then y2, that's fine as long as you also switch these two. So that part doesn't matter as long as they're both switched. So like the 1s line up and the 2s line up. What we cannot switch is our x and y. Our x has to stay in our denominator because it's our run. Our y has to stay in our numerator because it's our run. So we're going to do a few of these together, then I'll let you try some. For me, the easiest way to do this is to label which one is x1, which one's y1, x2, y2. Remember that these ordered pairs is an x and a y. So I'm going to go through and label this x1, y1, x2, y2. After I label it, it's just putting each number into the formula I have. So I'm going to do both of these to show you that they both work, but we'll do this one first. So my formula says yes.
So x2 plus y is the second x.
Yes, the second x and y. Yeah. Javier.
So do we write both of them?
You
y2
can.
minus y1 and the y1 minus y2.
Definitely this one. You can write this one if you want. Both of them are technically correct. So
Do we have to like use both? When you're talking about
you really just need this one. In this example only, I'm going to show you that both work, and then we won't do the other one.
So just to clarify, you don't multiply like 2 and under the y and the x.
Say that one more time.
So when you say like y, like y2 and like y1 and x2 and x1, you're not multiplying.
You're not multiplying. You're just, it's numbering them, the first x and y and the second x and y.
So you technically use the same variable, but if you
When you say use the same variable, what do you mean?
use x and y, but I mean like if you know, you don't have to necessarily put 1 or 2 if you know what you're doing.
Yes, but if you don't, I would use the numbers.
So we could also put m equals y1 minus y2 and also over x1.
Okay, so for this first one, we're going to use this one. So y2 is this 3. You're always subtracting no matter what, even if these are positive and if they're negative. So I'm subtracting my y1, which is 1. This needs to be in fraction form. Then I'm taking my x2 which is 4. I'm always subtracting. My x1 here is 1. So I'm going to subtract my numerator, subtract my denominator, and then at the end simplify. So 3 minus 1 is 2, 4 minus 1 is 3, so my slope is 2/3 because this can't be simplified. Okay.
So for that problem, we did x2 first and y2 first.
Yes.
Would it be the other way around?
I'm going to do it again for this one so you see that that's the next. So this one is not your actual formula. This way this works.
So if we had both negatives, like negative 3, negative 1, would you put negative 3 minus 1?
You would still keep the negative and keep the minus, which would make it a plus. We'll do an example of that in a bit. But going back to this one this way, now I have y1, which is 1, minus my y2, which is 3, over my x1, which is 1, minus my x2, which is 4. 1 minus 3 gives me negative 2, 1 minus 4 gives me negative 3, and a negative over negative is a positive. This is why this works, because you get the same numbers, both as negatives, and they cancel, the negatives cancel. If you switch one of them, but not the other, what's going to happen is you're going to end up with one being negative and one not being negative, so your whole answer is going to be negative, and maybe it shouldn't be, or maybe it should be, so that will cause an issue. For number 2, I'm going to go through and label these again. And start that process. So y2 is negative 2. I'm subtracting. My y1 is 4. My x2 is 10. I'm subtracting, and I have a negative. So you would keep both the subtraction and the negative because you're always subtracting no matter what. Say you.
So if we did it the other way around, for negative 2 minus 4, we put 4 minus parentheses negative 2.
Yep. Okay. Once you have that in there, then you can subtract. Negative 2 minus 4 is negative 6. 10 minus negative 2, this is really adding. So I'm going to backtrack and redo this. If you have a negative and a minus, after you've written like this, if you want to change this to a plus, you can do that. But what I would not do is immediately start with a plus unless you know that it's a negative and a minus. Just for the simple fact that you might confuse your equation and start putting pluses instead of minuses, which will throw everything off. So negative 6 over 12. Can we simplify this?
Yeah.
To what?
Negative 1/2.
How do you what? The negative and the minus come together make a plus. It's really mathematic happens. In your calculator, if you were to put 10 minus a negative 2, it would be adding and not subtracting. I want to see if I can do 3 more examples, but we'll see how much time we have. So for number, we're going to skip 3 and 4, go down to number 5. And do the same thing, label them. So we're going to have 9 minus 9 over 3 minus 5. 9 minus 9 gives us 0. 3 minus 5 gives us negative 2. What would this equal? 0. So when you're finding slope from 2 points, and you're using the formula, if you look at the 2 points and your y values are the same, you're going to end up with a 0 slope. But they have to be exactly the same, not like a 9 and a negative 9. Yes,
So
Eric?
we can just look at that and tell us this is.
Question?
Yeah.
Wait. For number 2, right? What do you mean by negative 4?
Negative 4. It wasn't negative. We're always subtracting, and we subtracted a 4.
So we don't add.
No. Even though the numbers are positive, we don't add. The only time we add is if we have a negative and a minus. I know that's confusing. Okay, number 6, same thing. This would be 5 minus 8 over negative 7 minus a negative 7. Five minus 8 would give you negative 3. Negative 7 minus a negative 7 would give you what? 0. Negative 3 over 0, over 0 would give you undefined. So just like number 5, if you get two ordered pairs and your x values are the same, you're going to get an undefined slope. Last one we're going to do is number 7. 7 through 10 are all very similar. I don't know if you guys have additional space on that. Not really. You may want to take out like a separate sheet of paper or write in like the examples, like turn your page over and write in an example. Because you may need additional space, you may not, I'm not sure. So for number 7, the process starts off the same way. But because we're dealing with fractions, we're going to have fractions within fractions, which in math is not nice, but it'll eventually simplify. I'm going to rewrite this on here so I have space as well. So I'm going to start this off 3/4 minus 2/5. That would be my y2 minus y1. All of this is going to be over 1/3 minus 2/3. And that would be my x2 minus x1. And we're going to go about this just like we would normally if they were regular numbers, but we're dealing with fractions. So we have to remember our fraction rules. We can only combine two fractions if they have the same denominator. And this part you can either do some of this by hand or use your calculator, so we'll do both. If you were doing this by hand, you would need to get common denominators for 4 and 5. The least common denominator between them is 20. So I would need to multiply this 5 by 4 to get 20. What I do to one part of the fraction, I have to do to the other. I would need to multiply this 4 by 5, and then same thing. What I do to one part of the fraction, I have to do to the other. And I'm going to focus on that part first. Now my numerator fractions have the same denominator, so I can combine them. My denominator fractions already had the same denominator, so we could have combined those already, but I was waiting. So now we're going to combine them kind of both at the same time. 5 minus 8 would give us 7 over 20. 1 minus 2 would give us negative 1 over 3. Remember, you're only adding or subtracting your numerators together. And now we have this not nice looking fraction within a fraction thing going on. So to simplify this, anytime we divide by fractions, we multiply by the reciprocal. So that's what we're going to do here. Multiply this by the reciprocal. But because we're multiplying one part of this entire fraction to the other, we have to do the same thing to the other. So multiply this part also. And now it's next. Have a good one. Good.
This part?
Hold on 1 second. Let me finish this and ask the question. The bottom is going to cancel completely and just become 1. This part right here is going to become 7 times negative 3 is negative 21. 20 times 1 is just 20. And then anything divided by 1 would just be whatever it is. So our final answer would be negative 21 over 20. It is. Javier, ask your question.
Fractions versus times negative 3, 1.
Uh-huh.
Is the negative for the previous or is it for both of them?
It's not for both of them. It's just for one of the numbers. It doesn't matter which one it is. Okay.
Do you always multiply by the denominator?
By the reciprocal of the denominator.
That's what I meant.
Yes. So when you get the ones with fractions, it's going to be a little bit more work. But you do end up with, sometimes the fractions completely cancel out and you're just left with a nice whole number. That rarely happens, honestly, but it does all work out. If you were using your calculator, you could have put in 3/4 minus 2/5. Figured out that was 7/20, so it would have skipped this part completely, which is fine. And then in your calculator, you could have done this, so I'm going to do both of these parts really fast. And I think this is about 37. So alpha y equals 3/4 minus 2/3. No, I did that wrong. Minus 2/5, my bad. There we go, that's the answer I was looking for. So you could have done that part in your calculator. You could have done this part in your calculator too, or still done that by hand, but I'll put this part in our calculator just so we have it. 1/3 minus 2/3. And then I'm going to go back and grab 7/20, and I'm going to divide that by this fraction. And it would give me that answer. So all of that work we just did by hand, you could definitely do in your calculator. Another way to write this, and I would not recommend this only because the fraction part gets confusing, but if you wanted to start off by writing it like this, you would grab a fraction in the numerator, make it another fraction, go down to the denominator, make it another fraction, and then put both pieces in there. And you would still get that same thing. Again, I do not recommend that because you may forget where to put the fractions. This part is easier because it's not as many steps.
Same thing, just written differently.
Yes. Okay. Did we have any questions on that one, Javier?
So, at the beginning of, can you get 3/4?
3/4 was given to us.
Oh, right. Oh, we're down to number 9. Okay, never mind.
So number 8 is going to be solved very similarly. 9 and 10, some of them have mixed numbers. You would need to make those in proper fractions first and then do this process. So that has an additional step. There is a button on your calculator that does that for you. If you hit alpha y equals, I want to say it's this one. Let's see. So the second one will give you mixed fractions. So if you put in like 2 2/3, oh wait. It will give you the improper fraction. I just hit enter and it did that for me. So that's a nice feature that your calculator has. You guys only have a couple minutes, so I'm going to let you go ahead and grab your phones now. Next class, we'll start with you guys working through some more of these problems, and then we'll continue in this.